in 14.1, we kind of did something called, I call it the language of graph theory. We did some definitions. And in 14.1, we had a definition of a path and a definition of a circuit. I'd just like to kind of tie this together, talk about some of the differences between these sections. In 14.1, among the definitions, we had path and circuit. In 14.2, we had a special kind of path and a special kind of circuit. In 14.2, we did Euler path and Euler circuit. Euler covers every edge exactly once. Every edge exactly once. And I'll put Euler at the top there. A lot of E's. Euler, every edge exactly once. So it's a big difference between the problems if they're asking you for a path or a circuit, or if they have Euler in front of that word, Euler path, Euler circuit. In 14.3, we are going to add another one in there, Hamilton path and Hamilton circuit. Let's see, Euler did every edge exactly once. What do you think Hamilton might do? Every vertex exactly once. So remember, Euler edge, Hamilton vertex. There is some bad news about this one. There's not a nice theorem like in 14.2. In 14.2, we had Euler's theorem that we could look at the graph, find the degree of each vertex. The graph had to be connected, something with even numbers of vertices. If they were all even and the graph was connected, we had an Euler circuit. If there were exactly two odd and it was connected, we could have an Euler path. We don't have that nice kind of theorem for Hamilton. So I'm going to write this as bad news. We do not have a theorem. I'll write nice, concise theorem that tells us whether or not a graph has a Hamilton path or circuit. So it kind of is some bad news. Mathematicians have studied these for hundreds of years. Well, Euler lived in the 1700s, so we're coming up on, I guess, about 250 years at this point. They've studied it and have determined there never will be a theorem for Hamilton circuits and Hamilton paths. They'll never have that kind of complementary theorem that we had for Euler circuits and Euler paths. So what do we have to do? We're just going to have to look at it and work with it with trial and error. To find a Hamilton circuit, or Hamilton path, we will use trial and error. And I don't really know when I'm looking at the graph whether or not it has one. If it's just a random graph they've thrown up there.